All right. I'm gonna wait a couple minutes to get started, just so people can start logging in. It does get a little laggy, so it might buffer a bit. So I'll try to write ahead of my words, because it takes, if I write and talk at the same time, you'll hear my words before you see them. Let me make sure it's working, because it's not saying it's working. Says I'm streaming, hopefully. Says people are watching. So I think it's working. Let's see. Let's double check. Yes. Yeah. Okay. So, like I said, I'm going to wait a couple minutes before I start, let people start coming in. I will try to write first, then talk, because I'm sure, as you're probably noticing by now, it starts to lag. I don't really know if that's just because of my internet or because I'm like streaming it from my iPad, airplaying it onto my MacBook. I'm connected to Wi-Fi, so I think it just slows everything down a lot. So, that being said, I should be understandable. I will just buffer and lag, and there's nothing wrong with that. So, just some ideas. Idea one, make sure you just memorize what you need to memorize. If you're walking in tomorrow and you get to a question, you're like, oh darn, what's R again? Then you didn't take like the 3 seconds it took to just like memorize something. And even so, if you've been doing what you should be doing, then you shouldn't have to memorize any of this, because we've done enough problems with them that they should just be, hopefully, with you. So just take the time to look over what Mr. G has politely asked you to look over on your own, and actually look over it, and that'd be great. I'm going to go over these tougher problems here, where some of them aren't even that tough, because the CASEL Learning is the basics and gives you the answers and explains them to you if you get them wrong. So I'm not going to really focus too much on the CASEL Learning. First thing to keep in mind, when you look at number 1, I forgot to give it to you, and of course you would think when I noticed this in 4th block, I would fix it and before I made it for you guys, and I forgot again. The specific heat for iron is 0.45. As you read this problem, you should notice that you have everything you need for water. So while this is technically an MCAT equals MCAT problem, you can solve for water first using all the information you have for water. So, you know it's 104 grams from the equation, or from the problem. You know the specific heat for water is 4.18. And then the temperature change for water is given. It's 4.6. And when you do that out, you'll get about 1999. And that means that the water has gained 1999 joules of heat, which means the iron has lost 1999 joules of heat. So, what that sounds like to me is the setup for another MCAT problem. This time, the information we know about the iron. We're trying to figure out the initial temperature of the iron. So the first thing you might wonder is, in my setup, why is it x minus 24.3 if X is my initial, not final temperature, and delta T is final minus initial. You'll notice that the water got warmer, which means the iron got cooler, which means the temperature for the iron went down. If I make 24.3 my initial temperature, or if I reverse this and do 24.3 minus X, you're going to get a negative number, and you're going to be setting this negative number equal to a positive heat, which doesn't make sense. So, you have two choices. If you know the initial temperature should be higher than the final temperature, just based on conceptual ideas of heat, then do initial minus final in your setup, because that'll get you a positive answer equal to a positive answer. Or you could do 24.3 minus X, but when you do that, you would have to make 1999 negative. So, first thing I'm going to do is combine everything on the right-hand side of the equation and then distribute. So when I do that, I get 22.7x minus 553. I'm going to add 553 excuse me, to both sides. That'll get me to about 2553 equals 22.7x. I'll divide 22.7 from both sides, and you'll get about 112. And you can tuck your answer by, again, plugging it in for x. So, if you were to plug that in for x, you would get 1999. If you did it the other way around and did 24.3 minus x, just make sure you get negative 1999. And the negative 1999 makes sense because that heat's being released. And we call that heat being released exothermic. And we represent that with a negative symbol. Now that I can see we're up to 11 people watching, if you ever have a question, shoot me a text on Remind. I do not open up YouTube comments just because it's easier for me to know who you are on Remind. Now, number 2, I was circling around a lot in class today, and this problem is actually a lot easier than we were initially making it out to be. First, Pivner is your friend. Pivner can help you solve almost every single gas calculation problem that you have. Use it. People are afraid to use it, and it's a great equation that just gives you all the information you need about a gas. Now, when I say we made this a bit harder in class, that's because I modified this problem in a way to make it easier to understand, but at the same time made it a lot easier to solve. Since I just told you you had 1.2 grams of gas in your balloon, that means you had 1.2 grams in the container at those conditions, which means you can just Pivner it using those conditions given. So when you set it up, instead of having to worry about P1, V1, T1, you can just Pivner it of the canister, because I just told you that 1.2 grams was in the canister and then came out and went into the balloon. So what did I mean that I modified it and that makes it easier? The original problem had more grams of the gas in the canister than in the balloon, and then you did not empty the entire canister into the balloon, therefore forcing you to do a P1, V1, T1. Since I just eliminated that part of the problem and just said you had 1.2 grams in the canister and then 1.2 grams in the balloon, you can just use the original conditions of the canister. You're going to divide away from your variable. So you're going to divide both sides by 0.0821 times 323. and you'll get an N that's approximately equal to 0.017. The question was asking, what is the final answer in grams per mole? So I'm going to divide grams over moles, and I'm going to get 71 grams. And that was it. If you're, generally speaking, if you're reading a problem about gases and you don't know where to start, try Pivnert. You can Pivnert partial pressure if you'd like. You don't have to sit there and memorize this partial pressure formula if you don't understand it, because you can get the pressure of a gas using Pivnert. Now, if the problem doesn't give you volume or doesn't give you temperature, can you assume it's constant? Maybe. That's where things get a little dicey. But generally speaking, Pivnert, PV equals nRT, is great. All right, problem 3. Again, when you deal with partial pressure, you have to convert to moles. You have to use moles. You cannot use grams. So, I'm going to convert my 14 grams of hydrogen to moles and my 84 grams of nitrogen to moles. So the first question you might ask yourself as you see this work pop up is, where did I get 2 grams for hydrogen and where did I get 28 grams for nitrogen? And quite simply, I got that from the periodic table. So hydrogen here weighs about 1. And in class today, I made a clarification that you should assume that you have H2 and not H. So if you have H2, it weighs 2. Versus nitrogen over here, again, we're going to assume we have N2, because I made that clarification in class. And 1 nitrogen weighs 14, therefore 2 are going to weigh 28. Whenever you're doing moles, it's always mass in the problem divided by mass from the periodic table. From here, again, you could Pivnert this. It'll be a lot of work, but you could. You could Pivnert based on the moles of each of your gases, but you don't know what the R value is for mmHg, so I would have to give you more conversions, or you could look it up. So let's do this the partial pressure way. The general formula for determining the partial pressure of a gas is you take the fraction of gases in moles. In this case, I'm using 2 because you were given the partial pressure for oxygen. So that mole fraction, gas divided by total gases times total pressure, will always give you the partial pressure. In this case, our partial pressure for oxygen is 78. So I can simplify this and say 1/6 of my total pressure is 78, because 2/12 is 6, is 1/6. I'm going to multiply both sides by 6, and I will get a total pressure of 468, which is my answer. And that's it. So, again, take the total pressure, multiply it by the mole fraction, part over whole, and you'll get the partial pressure. Since I was already given the partial pressure, I just need to work backwards, do a little bit of algebra, and that's it. Again, any questions on Remind, just text me at any time. Percent abundance. Again, I'm going to ignore those percent values because they're not correct. You don't know what percent of neon is 19.99, nor do you know what percent of neon is 21.99, but you know that the average mass of neon is going to be 20.18. So this is that x 1 minus x setup, where you can set x to be either of your masses, 19.99 or 21.99, and you can set 1 minus x to be either. It won't matter. You'll get the same answer. You do 1 minus x because you know both of these percents have to add up to 100, and since that we are converting these percents to decimals, both these percents need to add up to 1. So whatever this percent is there, x, 1 minus that value needs to be the percent that's left over. So we're going to distribute and combine like terms. So we got 19.99x plus 21.99 minus 21.9 is going to equal 20.18. We're going to combine our like terms. We're going to subtract 21.99 from both sides. And when you do that, what you'll wind up with is negative 2x equals negative 1.81. From here, do some more algebra. Divide both sides by negative 2. And now I'm getting an x of 90.5%. And the other guy is going to be about 9.5%. You might also get like 91% and 10%, or sorry, 9%, something like that. But that's what I get. How you doing, Mrs. G?
Hi.
You doing okay?
I just hear all this loosey-goosey math again. Depending on how you round. Just round correctly. Hi.
They are rounding correctly.
No.
Yeah. It's so delayed, I didn't even show up yet.
Hi, Harper.
Let's see. There you are. Hi.
Hi, Harper.
Okay. So, electron configuration. We're doing silver.
Hey, girl.
Let's go to the periodic table. Periodic table. All right. So, silver's right there. Woo. So you can't use your color-coded periodic table. Oh my God. But this is not that bad. This won't be that bad. So let's take it a step at a time. You always start at energy level 1. The first orbital you'll fill is S. So we got 1, S, 2. Go to energy level 2, S, 2. We're still in energy level 2 as we enter the P block. 2, P, 6. Still not at silver. So we're going to drop down to energy level 3. 3, S, 2. Still not at silver, so we keep going. 3, P, 6. Now we're at energy level 4 because we're still not at silver. 4, S2. Here comes the tricky part. Remember, when we get to the D block here, to these rectangular area of the periodic table, it's 3D10. Still not at silver, so we're at 4P6. We're still not at silver, 5S2. Now we're back to the D block. Remember to subtract 1. 4D. 1, 2, 3, 4, 5, 6, 7, 8. Right? 9. 9. I can count. 2, 3, 4, 5, 6, 7, 8, 9. Silver. Or, obviously, you can do it the lovely shortcut way. Krypton would end up be the first noble gas before silver. Fill in the rest. 5s2, 4d9. No excited state with these. No ions with these. Just basic electron configuration. Again, when I get to problem number 6, I am going to say hydrogen is H2 because it is, and that's what your answer is based on. I would always put the rate of hydrogen, because it's your lighter metal, on top on the left-hand side. And then when you do the weights under the square root, I would put that now flipped, because that's what the formula says to do. You flip it over here, and you put the weight in the denominator. So hydrogen's rate is how much faster than sulfur dioxide. Well, if you do 64 divided by 2 and then take the square root, you're going to get 5.63 times faster, which makes sense. So that's why I say to always put the lighter gas on top on the left side. So when you do the math on the right side, you get an answer that makes sense because hydrogen should be faster. Just a quick note, because I've noticed this a lot. Let's say you were doing a problem and you had all the information on the left side and you were missing some piece of information on the right side. So, yeah, I made coffee before and I wanted to save it for tomorrow so I don't have to make it again.
Okay.
You know?
You could have just nodded. I didn't want to interrupt. Sorry.
No, they could hear you, so it's a question that needs answering.
Okay.
You can't just ignore it. Okay. When you see a square root and you need to get rid of that square root, like the problem we have right now, you just take it and you square it. And when you square that radical, it goes away because a radical and a square are opposites, so they cancel out. Now, you also have to square the other side of the equation because what you do to one side, you have to do to the other side. So you'd be left with 8 squared equals 80 over x. And then you can just do your lovely cross multiplying and dividing. Don't square the x, don't square root the x, and don't forget to square the other side. Squares and radicals are opposites, they cancel out, but if you square the right, you gotta square the left. Right, Mrs. G?
Sounds
Back
right
me up,
to
math teacher.
Math teacher approved. Thumbs up.
Okay.
Trying to peel an egg over here.
When you end up getting to number 7, what is the normal boiling point of a substance? Boiling point is where the liquid and gas lines meet. Normal means STP. So STP for this case is 1 atmosphere. Draw that line from 1. Draw that line down when it hits the liquid and gas segment. And you got the boiling point, which is about 80 degrees Celsius. And that's it for the hard ones. I would really just make sure that you know Pivnert exists and you use it. If you go through this whole test tomorrow and you don't use Pivnert once, at least once, you goofed somewhere. Because Pivnert is Pivnert, and Pivnert is important. I'm going to keep it open on Remind for questions, but if not, I'm going to sign off in a couple minutes, and you guys are going to have a great night, and you're going to kill it tomorrow. Kill it. Kill it. Need like an air horn.
Yeah. Hey, you can't have these.
But dude, questions. She shouldn't eat almonds.
But she's so cute.
I know, she really loves almonds. She also really loves chocolate. And you know what she doesn't or shouldn't be eating? Chocolate.
I'm not gonna get
Right, Harper? Yeah. No.
But she's so cute. Hi, I love you.
Can I do another partial pressure? Yeah, I can do another partial pressure.
Never pot.
Let's say you had 20 grams of neon, 10 grams of oxygen, and the total pressure is 100 kPa. What's the partial pressure for each gas? So, we got to take our grams there and convert them both to moles. So 20 grams of neon was given. Neon weighs on the periodic table 20 grams. So you have 1 mole of neon. 10 grams of oxygen was given. And oxygen weighs 32 grams, again, from the periodic table. And 10 divided by 32 is going to be about a third. 0.313 moles. Add up our total moles, and you'll get 1.313. Let's do neon first. There's 1 mole of neon. The total pressure is 100. So we're going to do 1 divided by 1.313 times 100, and neon 76.2 kPas. And oxygen's just going to be 100 minus that, because there's only one other gas in the container, and that'll give you 23.8 kPas. Someone asked the question, are we going to send abundance of isotopes with 3 elements? No. No, you will not. Lucky, lucky, lucky. We did a couple of those as practice. I think that was good enough. Comfy?
She's so cute.
She's like, this is comfortable. I love it.
Did you miss me?
Again, partial pressure is all about mole ratios. Mole ratios times total pressure equals partial pressure. How much gas in my container do I have? How much of that is nitrogen? There's your fraction times the total pressure. You get the partial pressure. Did I tell you I ordered beef jerky from a hockey player?
Why are they selling beef jerky?
Not
What are you
only
doing,
beef
Torres?
jerky, they're selling just meat, like Slim Jim, and like just meat. So
Is it all cooked?
no, it's like
Like, can I buy the steaks?
it's like cured meats.
With kielbasa?
Probably, I don't know. I
It's
didn't look
so
at it.
weird.
So I just spent $40 on beef jerky.
If any hockey players are on your live stream, are you guys gonna sell hockey hats? Like the winter ones?
I don't know. The only hockey player that can potentially be on my live stream is Sir Doug Johnson. And if Sir Doug is not on here watching, then you're
Out of luck.
out of luck.
I don't know whether to buy one from the senior class or the hockey team. I'd rather buy it from
I would suggest not buying $40 of beef jerky, that's for sure.
Why didn't you do that?
Because I'm a sucker.
You know someone else is selling cookie dough, right? Could have at least bought something good.
They didn't approach me. I had like 5 hockey players knocking on my
You
door
bought $40.
looking to sell beef jerky, and I pissed off a few of them because
You bought $40
this
for
one
one
kid
kid.
got to me first.
That's a lot of beef jerky, though.
You know how much beef jerky it is? A pound. It's 2 packages. It's not that much beef jerky at all.
Oh my god.
I would love to hear a joke, Jason.
Is it about beef jerky?
I don't know. We're gonna
Is the
find
joke
out.
Mr. G bought $40 worth of beef jerky?
Yeah, want to hear a joke? Sure. Did you hear Mr. G bought $40 worth of beef jerky?
And Mrs. G doesn't eat beef jerky, so it's all you.
Maybe that was the whole point. You eat cookies. I eat cookies. Now I have to share. You don't eat beef jerky. I only eat beef jerky.
The way you say that makes it sound like beef jerky is the only
Winning.
thing you eat.
Maybe it is.
You look great for all that sodium intake. Harper, stop licking the stove.
Jason, this better be a great payoff, because this joke is taking forever.
Is it a good joke?
It's punny.
Is it about turkey?
All right, guys, you're going to kill it tomorrow. Don't worry